Welcome to Better Worlds Ocean, where we dive into discussions on cutting-edge technology, data-driven solutions, and groundbreaking innovations aimed at tackling oceanic challenges. Join us as we ride the crest of a new era in global sustainability and work together to preserve our oceans for generations to come.
Welcome to Better Worlds Ocean, where we talk about how next-generation technology and data and innovation can address ocean challenges and lead a new wave of global sustainability. I'm Kate Wing, and I'll be your host for this series. Erika Montague is my guest today, and I am thrilled to have her. She's the Chief Technologist at Schmidt Marine Technology Partners. She's an oceanographer, explorer, and evangelist of technology for a healthier ocean, with a PhD in oceanography from Johns Hopkins University. Her past research has involved work with submersibles and unmanned vehicles, with a focus on the development of novel, non-destructive methods for studying extreme and remote marine environments. Erika has led cruises to study bioluminescent life forms and marine debris, and she's tested underwater technologies for use at the surface and down to the deepest parts of the ocean, including working on the land and submersible teams for James Cameron's Deep Sea Challenge expedition. She aims to bridge the gap between diverse stakeholders to create a more sustainable technology world, and she works on outreach efforts that leverage the technology-driven culture of today to empower the next generation. Welcome, Erika. Thank you for joining us today. And can we start off by you telling us something that you're excited about today about the ocean? An animal, a trend, something you just learned. What's getting you hyped about the ocean right now?
Yeah, hi, Kate. Good to see you again, and thanks for having me on this. What's getting me excited? Well, there's a couple different things and they're in two very different directions. And one of them is kind of the power of something very simple. So I've been very excited about how people have been able to take back old traditions and really reclaim parts of the ocean and improve ocean health. And a good example of that is oysters and what they're doing in Shinnecock Bay, and what an incredible success story this has been just over the matter of a few years, where it was the worst water around New York, and they were having brown tides, they were having red tides, which cause toxicity in a lot of organisms, including the ones that we eat. And they started improving this habitat by adding more and more oysters. And it just sounds like such a simple thing, but it's this whole cascading effect. And now they're doing more studies, and then they're employing really cool new technologies, something called environmental DNA. So you, me, trees, fish, we shed cells, those cells that have DNA in it, and little pieces, and that's in the environment. So in the ocean, people are taking water samples, and then they're looking at these little pieces of DNA to try to understand what organisms may be present, and then they're comparing that to other methods. And right now for Shinnecock Bay, they're seeing this whole new diversity. They're also seeing types of organisms, types of sharks that they thought no longer existed there. So that's super exciting. So that's one side of it. And I think the other side for me, and we can dig into this later if you like, is just the idea of how, certain technologies have been there, but there's another technology that needs to occur in order to enable it. And so, for instance, we've been able to do a lot of imaging and a lot of stuff with light over the years, but lasers are very power intensive, and LEDs have been around for a long time, but they just haven't been specific enough or powerful enough. And now with something just so simple as better LED technology, we're able to make all these incredible sensors that are lower power, smaller, lighter weight, cheaper. And so now we can go and deploy these in many more regions to look at everything from nutrients to imaging types of organisms. So these are the types of things, these synergies that are really exciting to me, to try to get a better grasp on the bigger picture, but then also like really improving the habitat.
There is some great stuff in there, and I want to talk a little bit more about environmental DNA, eDNA, and those LEDs too, because one of the things you as a deep sea explorer have looked into is, of course, the hunt for the giant squid, the search for the giant squid. And I remember the stories you and your mentors and colleagues have talked about with how do you find things in the deep ocean. I had a professor tell me once that, the joke is that counting fish is easy. It's just like counting trees, except they're invisible and they move around, right? It's just like anything else, except it's really hard to track them. And when you're in that deep ocean, how did people even figure out that putting lights, setting up LED flashing lights would attract organisms? That light is how organisms communicate in the deep sea. And can you imagine what the work would have been like 10, 15 years ago to find a giant squid if you had these low cost, low power sensors?
Yeah, well, we did start working with LEDs to try to attract squid. And the person that came up with that hypothesis was my PhD advisor, Edie Witter, who is a remarkable woman and a really impressive work in the area of bioluminescence. But we understood for a long time, not just Edie, but a lot of folks that, why would animals use light in the ocean? It's energetically costly. There must be a reason why they're flashing. And so there's a lot. There's reasons where they're trying to communicate with each other or communicate to a potential predator, or sometimes trying to hide from a predator by using counter illumination. So just like we see a lot of times, sharks are dark on the top and maybe lighter underneath. That's because if something's looking up, they can't see it with the sky. And if they're looking down, it blends into the bottom. And so in the open ocean, there's no real place to hide, and animals have really adapted to be able to see the tiniest types of shadows in the deep ocean. And so these organisms have created little photophores lights that emit light and blur around them, so their silhouette disappears to a predator. I mean, it's just some super impressive stuff. And so with the squid, we just wondered, why on earth would squid, who are hunting so deep, have such big eyes? So they must be looking for something. And the thought was, okay, well, they're looking for something and there's all these jellyfish, and like, why do jellyfish light up? And some theories say maybe they can see the light, but in general, they're not seeing their own light. And so the idea was to flash this light to create some type of signal. And so they call it the burglar alarm theory, where it's lighting up like a car alarm as another predator, a fish, is trying to attack it, and a secondary predator, or the cop, would be able to see it. So something like a squid would actually see the light from this jellyfish, go over to investigate, and realize there was something there to eat, this other fish. And over time, we think that they've evolved to realize that now and actually target it. And that's exactly what we saw with video, was that they were targeting it. So now this sounds really neat, right? We can pretend and mimic to have a bioluminescent jellyfish and different signals that we've seen in the deep sea, to mimic that predator and then see what their behavior is. But in order for us to see it, we actually have to use light also, and we don't want to scare them away. So now we have to use red light with a really intensified camera. And this gets into those areas of how technology has changed. So the camera system I used, I had to wait months to get, and it had this very, very sensitive intensified camera that could see the red light, which quickly it attenuates in water. So like that's why it doesn't go very far, right?
Right.
And then we also wanted to be able to see the blue bioluminescence. And so it was, thousands and thousands and thousands of dollars. Now, some of the camera systems off the shelf that are out there can see bioluminescence, can see red light in water. I mean, they're just, and it's so much cheaper. So, something that was a huge part of my research budget now could be much cheaper. And even the LEDs are better. They're brighter, they go further. So I could illuminate a much bigger area, field of view. And so, yeah, so in that respect, things would have been much cheaper and easier to see, and possibly more efficient. And
I love this concept that basically we humans are starting to evolve technology that is 2,000 years behind what animals have already evolved, just that we can understand them, right? Like what we're doing now is catching up with the world that already exists. And that's great to open our eyes and ears and photoreceptors to really connect with the world, to understand how we can measure it and how we can protect it and restore it. And so let's talk a little bit about what you do at Schmidt Marine Technology Program and what are the things you're looking for and looking to accelerate in the ocean world.
Sure, yeah. So Schmidt Marine's been around for almost 8 years now. And it was started because the group believed that there was really funding that was lacking in this area where a researcher at a university or perhaps a startup company has this really great idea and they're starting to work with it, but they just lack the funds to get that idea to the point of commercialization, to the point where someone's either going to invest in that technology or they can actually sell that product. And because of that, a lot of technology was not getting out into the world because that early stage funding, that non-dilutive grant style funding was not available to those groups. And so what Schmidt Marine did is said, okay, let's look at the areas where we think there's a lack of funding and there's gaps in funding for these types of technologies to get out. And let's start a grant making program. And so we look at technologies that can help with understanding the ocean better, help with sustainability in the ocean. And we give grants to those groups and to the point where then they can get to a stage where they can actually commercialize that product or get investment. And we focused on a few areas in the beginning, again, that we thought were really lacking funding. So one of them was sort of the stuff that I used to do, which is enabling ocean research, building tools and technologies to better understand the way organisms move, light in the ocean, nutrients, a whole wide swath of things. The other one was fisheries, which I know is near and dear to your heart. And those would be technologies that either improve transparency in the seafood supply chain or limit bycatch. And then the other one was habitat health. And these are pretty broad categories, right? But these were technologies. They could be everything from very low cost, simple technologies to something that was much more elaborate. And a good example is and they grow at an order of magnitude faster, microfragmentation. And so we fund Dr. David Vaughan, who invented that technique. And then finally, pollution, marine pollution. And that's an area where we have started to back away from a little bit, mainly because a lot more funders are coming into this space. And so again, we really wanted
specifically
to identify,
in pollution, really?
In plastics.
Oh, right.
Yeah. And I thank you for asking that question, because we do fund for a couple different types of pollution. And one of them we're actually driving forward in and trying to fund more groups in, which is nutrient pollution, which is a huge issue. There's a lot of problems, including the plastics, but there's several people, again, that are coming on board to fund in that space. And not as much in the low-cost nutrient sensors or mitigation as much as we'd like to see. And then the final area that we don't fund necessarily, but we're starting to, but we've been very active in, is really trying to pull the different communities together to open up the conversation around ocean technology, around ocean funding. What are the problems? What are the needs? Convening people together to communicate about this more, trying to see more funders in the space or more technologies, and really opening up that communication because, again, and this is a whole another wide topic, things are quite siloed. And so we want to make sure, and we've also started to fund now groups that are actually also driven in these community efforts of opening up those conversations or getting more technologies out there. But that's sort of the simplistic view of what we do. We both fund and we're both active in the conversations within the community.
Yeah, and I want to touch on that a little bit because that's also a space where I work, since I'm one of the co-chairs of the UN Ocean Decades Data Committee. And the push for the UN Ocean Decade, which is happening now, it's a decade from 2020 to 2030. So we're underway with this charge to globally create the science we need for the ocean we want. And a key part of that is what they call co-design, and what we're kind of calling co-production of knowledge or co-creation of solutions with the communities that are going to use them, right? So it's not as though someone's coming in from the outside and developing a technology and selling it. It's really a solution that is designed with and by the people who are going to be using those sensors in their coastlines, in their areas, trying to measure carbon sequestration or track the the progress of a restoration project. That's what we're looking to see from the UN Decade standpoint. And I'm curious how you support that from Schmidt Marine, and where you're seeing that happen.
Well, we are actively trying to support this. We're also trying to understand how to best support it. And that has been a challenge to understand, find the groups that need support, how to support them best, both through funding, introductions, conversations. What this is a space that needs a lot of work. But you hit on a really important point, which is that a technology broadly, in the broad sense, is only as good as the number of people that are going to use it. And so that technology really has to be something that is applicable to those groups, those users, is easy enough for them to understand, is available. And along those lines, we've funded it a couple different ways. We've funded some groups, some of our grantees, that to have their technologies deployed in regions where it could be very useful. And the other way is to try to go out and find leaders in the community that are trying to find solutions. So there's a seaweed collective in Tanzania that we're funding, and they, this woman, she has created this whole community of women on how to grow, how to harvest, and how to make products out of different species of kelp. And a real driver in her community, the idea of locally grown, locally sold. And so we're actively seeking people like that. Now, how do we find them? We talk to a lot of folks. We hope that maybe they find us. But this is an area that needs work. It needs a lot of work. And I'm sure you're familiar with the Cities Project through the UN, where the leaders in those different cities are coming together and saying, okay, what does our city need for around climate change? What kind of technologies, what kind of communication, what kind of education, and how are we going to support that? And so one of the questions that we have, and I've talked to other groups about this, is okay, that's in one region, but what does that mean in terms of communication and support in the US versus China versus Norway versus Kenya? Each one of these areas are going to be very different. And so as part of that, we're really trying to talk to as many people as possible and find out how do we get the word out there, and how do we best support that? And is it a language barrier? That's probably part of it. And then part of it is just, again, some of these technologies are being built by people in regions where the people that will end up using them the most are not from. And so we really also seek to find grantees that are very actively communicating with people in those markets.
Yeah, it is a lot of work to really connect with and be in a community and understand what is the innovation that is going to be most beneficial and most readily adopted by that community. And I think one of the really important things of groups like yours and other groups that are putting out non-dilutive funding, small grants, small development grants, is that it takes time to do that research before you even know if you have a product, before you even know if you're going to develop something. So that's something we're seeing from the UN Decade standpoint, is what are ways that we could get kind of micro payments, small payments out into the world for people who are still at the ideation stage, people who are still at the listening stage, because not everybody can afford to stop working for 2 months to scope out a project idea. That's not something that is available to everybody. But to really do that deep thinking, we need to find ways to support people in that early listening and thinking stage.
Yeah,
So
I'm glad you mentioned that. We do support a couple different ways. One, we do make some microgrants to groups to sort of suss out what they're doing and help them support them in those early conversations. And then they may end up later becoming a much larger grantee. But another group that we support specifically does microgrants. So we give them funding to go out and then deploy the microgrants themselves. And that's experiment.com. So David Lang's platform. And we've been really excited to see the projects that come through that. And that is open to anybody. And we're hoping through funding like that, it can be a force multiplier to our paths of communication. Experiment.com is going to have even a larger one, right? And so that's another mechanism.
Yeah, I'm hoping we might get David on one of these recordings coming up, but that is a really amazing space where scientists, researchers, and others can get funding, but also have a crowdfunding platform for research. And it's really, it makes it a pretty light lift for them. Not every scientist wants to set up a Patreon or write a Substack every week or something like that. There's a lot of new ways to get your information out. But with experiment.com, not only is there a little money to start you off with, but you can get going. Look, this is a free advertisement for David, so he totally has to come on the show now. It's like, what am I doing? Selling David's platform. But it's a good platform. And I'm curious, like, are you seeing things like smart contracts or, blockchain tracking data, are those coming up as innovations for you? Are people starting to propose ocean innovations in that space?
They are. They are through a variety of mechanisms, both in terms of we've seen it for tracking in the fisheries. So the idea that the fishers can buy, sell, move their products around through a mechanism like this. We've seen a lot of this coming out of places like the Global South and Africa. And I do think, at least from my understanding of communicating with other people in other industries too, that for banking and a variety of things in Africa, this works really well because of the way they do so much on their phone and the way in which the operations exist. It's an area that's really ripe for those types of technologies and very much evolving. So that's a great example of where it may take a little bit longer in a more established area and region that has a specific way of already doing their operations. So we've seen it along those lines. We've also seen it in terms of potentially funding. How would you fund different groups through a process like that? But really, I think that the big area we've seen it quite a bit is in the fisheries. The idea of using that both to track and also for payment purposes.
And as someone who is not just working in the innovation finding and solution finding space for the Schmidt Marine Technology Partners, but also connected to this global community of venture capital investors and other investors looking to support ocean innovation. This is a really growing area of interest because climate funders are coming into ocean because you can't solve climate issues without solving ocean issues. And more interest is coming into this kind of ocean startup space. I'm curious if you're seeing lessons about what's working and not working being shared across the other people trying to support this work, because it's one thing for the individual innovators and researchers to learn their lessons themselves and maybe publish it here and there. But as the people who are trying to catalyze this work, how do you make sure you're sharing what's working, what's not working on a global scale so that we can really target our resources to things that have the best chance of success, or to people who are not getting resources and are maybe overlooked and needs that global network of investors to really look for where the gaps and where the bright spots?
I'll retool that question a little bit because I want to take a step back. We were very early in the space of funding ocean technology for, let's say, for sustainability as a shortcut. And now we're seeing a lot of people jumping into this space. But in the earlier days, it still is a lot of education. We felt that a big part of our job was to go out, like I was saying earlier, with the community and not just educate the new potential funders, but also educate the people looking for funding on how to communicate and find those funders. So really trying to be that conduit between all those different groups. And one of the things we found, well, two of the things we found in the early days is that, for one, scientists and engineers are not great communicators often to folks outside of their industry, myself included. It's been a long process to learn how to try to say things differently and in a more digestible and tangible type of format. And then the second part was that funders were really excited about this space. Like, we want to do something meaningful in the ocean space. We want to do something with the blue economy. But they wouldn't put their money in. They were very hesitant. And I think they were hesitant because it was hard for them to understand the space, because the space is very complicated. And I'm talking about new funders, not, people that have been in the industry for a long time for shipping or something. And then also the fact that if funding and your return on investment in the space is usually going to be quite different than in other tech industries, something like software. It's going to be a longer period of time. It's going to, instead of the 5 years, you might be looking at 10 years. And so getting funders comfortable with that idea, where are you comfortable? How long waiting for your return on investment? And then what does your return on investment mean? And so those are the areas where I'm seeing people get more educated and more comfortable about. So on the funder side, and then also on the innovator side of learning this world of how to communicate better. And oftentimes we find that a lot of these groups may need to bring another person on their team. Bring that person that's super comfortable with those kinds of communications and knows how to do that and knows how to build the business. And those are the teams we get the most excited about, are the ones that are open to learning, open to bringing other people in and making their product the best it can be and giving it the best chance for success out there. I'm not sure if I completely answered your question.
I think it's a really good comment on the need to recognize that these solutions are solutions that are implemented by people, and understanding what the people who are designing, building, and deploying these solutions need in terms of support, whether that's funding or advice or help getting other funding, is a process, and it's not just a check. And I think that is something that, as all of us who are interested in this kind of triple bottom line space, where people come in and they're like, I want impact, and I want profit, and I want innovation, and I want all of these things at the same time, and possibly at equal amounts, when in reality it can be harder to say, well, what does it mean to have 10x impact instead of 10x profit? But that impact is what a lot of us are looking for in terms of this long-term global sustainability. It can't just have one at the expense of the other, and figuring out how you're going to make those trade-offs and place your support wisely is a process. And it's great that you're supporting other people in the space as they get educated about how to understand and communicate impact.
Yeah, and we are seeing some success too in different spaces where people are starting to get clever, and we've learned from grantees. They've gone to people and said, look, we found funding through this part of the industry because we found out that they need to tick this box to do this thing, and insurance would be one play like that, right? Where a type of technology helps insurance companies either feel more secure about, let's say if it's a ship, right? That it's a safer environment to something like maybe some sort of shoreline restoration, where it's insurance for a hotel or a region. That one's still a little tricky, but people are investigating that too. And so those are areas to try to get funding. And then along those lines, of course, you have to show the industry and how you get that traction to an investor, for the investor to feel comfortable. And so these are all the little things that have to happen. And an investor to really understand that this is a different space.
Yeah. Well, is there anything else you want to help our audience get familiar with when it comes to ocean tech and innovation, or some words of wisdom you want to leave people with, that they're thinking like, oh, I have a great idea. I'm pretty sure that this could get us somewhere and help us have the next great oyster reef cleaning the entire, Shinnecock Bay story. What words of advice do you have for other people who are trying to pilot their ocean innovation?
Well, for one, I'd say that you don't have to be a person that comes from the ocean space to have a great innovative idea. I do recommend that you talk to a lot of people in the space to understand, maybe some of the nuances or challenges of working in the oceans is very different. But what gets me excited is that there's a lot of different tech out there. And so if you have a really compelling technology that you think may work in this space, start talking to folks, talk to us, talk to other people that are developing tech in that area, to see, is this possible? Because again, like I said, there's a lot of neat innovation coming up in other spaces, in battery technology, in LEDs, and all those sorts of things, that really could improve a lot of the current equipment or ways in which we try to understand the ocean space. So that's one thing I would say. And the second is that an area you're going to hear a lot about, because climate change, right? Climate. It's true. But that area has been such an interesting evolution for me and for watching my colleagues. We always felt the worst thing you could do is re-perturb a system that's struggling to rebound, right? Don't do something new because you don't know the consequence of that. But now we're realizing that we just simply can't get to the numbers we need to just by turning off the tap. And so now we have to actively draw down that CO2. And how do we do that in the best way possible? And that has gone in a conversation from 5 years ago. Again, people saying, we don't want to put something new in the ocean to try to pull in this carbon that then could have new consequences, to, okay, let's start to kind of research it a little bit, to, we need to throw a lot of money in to research this now, to rapidly iterate on this. And so I say it's sort of the NASCAR Formula One style of getting something done, right, over and over and over as quickly as possible until you have the right technology to do the job. And that's where we're at now. And so now all of us are really hammering away at trying to find those solutions and to validate them as soon as possible, because we need them. And we need more success stories like the Shinnecock Bay at a very big scale for the climate.
Yeah, so that's our call to you with your brilliant ideas watching this, to get involved and to get your innovation underway and help us develop the new sensors and tools that we're going to need to measure what's going on and to measure how we're fixing it. So thanks, Erika, for joining us, and thanks to all of you for joining us as well. We'll see you on the next episode.
Thanks for having me, Kate.